Me. Oh, there's a pocket.
Oh, this is set for the yes.
Name tags. Michael. Dimitri. Bart. Annie. Julian. Nine. Half of this.
Because of the wild.
Okay, I have not been very responsive on emails. I apologize. I've been busy with my research stuff and fallen behind. In any case, I have emails that I did open and downloaded Maple files from Annie, Tony. They both sent me one. Tony's, I think, is a little more complete. Am I right?
Yeah.
Okay, so Tony's is the one we should be keeping. Also Umsen sent me one. And they're the ones I had. Parth and Michael, I have theirs, but I'm not sure which version is my latest version. So, because I've got them emails and downloads, and so you'll have to show me which one is the right one. And who else has made a Makelet that you want me to have? And did you email them, or not yet?
Not yet.
Not yet. You're still going to work today?
Yeah, just see if we can fine-tune it.
Okay, and so it's you and you.
Same
Okay. Anyone else? Have you made one? No. Nothing you're ready to turn in?
No.
Okay. You were working on something, but you missed Thursday.
Yes.
You can work today, and if you work afterward, you can still give them to me, and I'm happy to have them. Okay? What did I do with that? They're probably on the chair in my room. I'll get it before we go down to the computer lab. I have completion certificate saying you did the complex circle, and also I have copyright transfers. That is something for you and your parents to sign saying that you're turning over your Makelet to me, and that if I want to include it in a commercial product, I can. Otherwise, I have to throw it away and get somebody else to write it, or write it myself if I want one on that topic. If you give it to me and it's on there, then on your college applications you can write, I wrote something that's in a commercial product, and give a link to it if you want the table of contents. Anyone else have one that they want to turn in? Did you email it or not yet?
No.
You're going to work on it today yet?
I can add a hint, but
Pardon me?
I can add a hint, but
Okay, and then email it to me at the end of today, or from home afterwards, okay? For better or worse, these accounts at the university are going to die probably at the end of the summer, okay? And they'll stop working. They should work all the way through the month of July, at least, okay? But then I can't say that for sure. Okay, so today we are going to prove the trig identities again. And who missed some last week? Mark and Julie. Okay, and so you saw the definition of the complex exponential. Julie and you did not. Okay, so I have to review that, and then we'll come back to doing identities. Okay.
Yes. Is this the last class?
Yes, it's the last class. unless we get together again in August. Okay? And a couple of you have asked me if you can work at CMAP as junior counselors.
Oh, yeah.
And the odds is yes. I haven't yet put together my list of counselors, so I'm behind on that too. Can't keep it up with it all. Anyway, last time, a week ago, we did the function cosine plus I sine of an angle theta was cosine of theta plus I sine of theta. And that combination occurs in anytime you have a complex number. It's written in r times this is it written in polar coordinates. So z equals x plus I y is equal to the magnitude of z times the cosine plus I sine of the angle theta. So you plot the point, here's x, y, which we think of as x plus iy. This is the real axis, this is the imaginary axis, and so we've come over amount x and y, and that's the point in the complex plane, x plus iy, and it determines a length here, which is the length of the complex number z, which is the radius in the polar coordinates, and then there's an angle theta, which is the argument of z, and so z satisfies this because x is z cosine theta, and y is z length of z sine theta. Okay? It turns out that this cis function has beautiful properties. Cis of CIS of alpha plus beta is CIS of alpha times CIS of beta. Okay, so and CIS of 2 alpha is then CIS of alpha squared.
Who's here?
I see we snuck in. And you can continue this and get CIS of n times alpha is CIS of alpha raised to the n power. And that behaves exactly like an exponential. So if I have a base b raised to the 2 alpha power, that is b to the alpha squared. B to the n alpha is b to the alpha raised to the n. And so b to the power is the same as CIS. Behaves much like it. B to the alpha squared b to the 2 alpha. B to the n alpha is b to the alpha raised to the nth power. These are standard properties of exponents. Consequently, there is some base that CIS mimics. And it turns out that CIS of theta is e to the I theta. So e to the I theta is another name for cosine theta plus I sine theta. And as we start learning about it, we use CIS. Afterwards, we use the exponential notation. And at this level, where we're purely using algebra, it is very difficult to justify this relationship more than just that it has the right properties. And this is a definition of e to an pure imaginary number. Okay? However, when you learn calculus and learn derivatives, you will discover that this function and this function have the same derivatives. Also, when you learn to approximate these functions by polynomials, these have the same polynomial approximations. And so all of those are better justifications for why one recognizes them as the same function. Okay? In any case, any complex number, z, can be written as the length of z, e to the I, argument of z. Theta. Okay? And if you have two of them, length of w, e to the I phi, then their product, z times w, is the length of z, length of w, e to the I theta plus phi. So the magnitudes multiply the phases or arguments add, okay, for the two functions. And we looked at the plots of these things. And so if you have 2 points here and here in the complex plane, they have radii. So this is magnitude of z, magnitude of w. This is the angle theta. This is the angle phi. You add the angles. So that might take me up to somewhere like this. And you multiply these lengths. So depends on if they're bigger than 1. If they're both bigger than 1, then their lengths multiply and get bigger. Okay? If they're less than 1, they multiply and get smaller. If one's bigger than 1 and one's less than 1, it's somewhere in between. But in any case, the magnitudes multiply. This is magnitude of z, magnitude of w, and the angle is theta plus phi. Okay? Okay, so everybody was here last week, saw all this, right?
Yeah.
Okay. Now, if I write this out, and let's take a e to the I theta is equal to cosine theta plus I sine theta. And e to the minus I theta is cosine of minus theta plus I sine of minus theta. What is the cosine of minus theta?
Minus cosine theta.
No minus outside.
Cosine theta.
Right. So we just throw away the minus sign. It just becomes cosine theta. What is sine of minus theta?
Minus sine theta.
The minus comes outside. So that just becomes that. And you'll notice that this one is the conjugate of that one. You reverse the sign of the imaginary part. Okay? So e to the I theta bar is e to the minus I theta. And the rule for taking conjugates is basically everywhere you see an I, replace it by minus I. Okay? And so now I want to, okay, I'm going to get rid of this. And who am I going to call up? I need an assistant. Who have I not called multiple times? Who would like to come up? Your hand went up first.
Yes.
Okay, here you are. Add those two equations. Add these sides. Just copy them down, add it together. Write this down.
Right there.
No, left-hand side. Add the left-hand side. Plus. Equals. Add the right-hand sides. Okay, and now does it simplify the right-hand side? That's correct. Don't erase, just write another equal sign. What do you get? What's cosine theta plus cosine theta? Right, and now solve this equation for cosine of theta. And write it up here. Cosine theta equals. No, just you're solving this for cosine theta. So what do you have to do with the 2? Divide this.
Oh, I see. Okay.
Cosine theta equals Yep. Okay. Now you'll notice that here we have an expression for the cosine of theta in terms of complex exponentials. Okay? Jeremy, come on up, and I want you to get a formula for the sine of theta. You can take your backpack off. So by adding these two equations, we got the cosine. What do you have to do to them in order to get the sine? Okay. Someone's phone. Turn it off. Mark, keep your hands to yourself. Are you following what's going on the board?
Kind of.
Okay, so that simplifies to okay, so sine theta is equal to okay, for 2i, that's right. Okay, now I'll summarize them over here again. Sine, these are my bad pen. So I hit with a pen. Sine theta is e to the I theta minus e to the minus I theta over 2i. Cosine of theta is e to the I theta plus e to the minus I theta over 2. Okay? All right, so what we would like to know is what is sine theta times cosine theta. Okay, Andy, you're on. Okay, so just multiply together those two quantities. Turn it into exponentials. This one and that one? No? You're right. Minus e to the minus I theta times e to the minus I theta is minus 2I theta. Now what about the cross terms? Why not?
It's like x minus 2 multiplied by x plus 2.
Okay, so it's what's called difference of squares. A minus b times a plus b. Okay, so you get the difference of their squares. Okay, equals, factor out a half. 1/2 times what? What happens to the 2's up in the exponent? All I ask you to do is factor out a half. Everything else stays the same. 1/2. Make it big. All you did is take a 2 out of the 4, right? All right, now look at this fraction. Don't go away. You're not done. Look at this fraction. Everybody look at that. And compare it to this. What's another name for that fraction? Compare it to this one. It's got a 2i in the bottom. It's got a minus sign between them. This is an e to the I theta, and this is an e to the minus I theta. This is e to the 2i theta, and an e to the minus 2i theta. How do they compare?
They're the same
Except
Top F squared.
because.
Except the theta here is replaced by 2 theta there,
Yes.
right? So this is equal to sine of what?
2 theta?
Write that down. Equals 1/2. Everybody understand that? You have just proved the identity. Sine of 2 theta is 2 sine theta cosine theta.
Interesting.
Okay? What's the identity for cosine of 2 theta? Anybody remember what that identity is? Come on, you should remember it by now. Cosine, cosine minus sine, sine, right? Second half of the trig graph, except alpha and beta are both thetas. So what is this?
0.
No,
1.
no,
E.
that's correct. Cosine squared theta minus sine squared theta. Okay? Prove it. Okay? So, you're on. Yeah, well. So, I want you to compute. We're proving it using the complex formulas for the trig functions. So, start with the right-hand side. Cosine squared theta minus sine squared theta equals. Plug in for cosine theta and sine theta, what they are over here, and then simplify everything. So you have to write, copy cosine. Big, 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 big. The class needs to see it. Same size letters as I've written. Your I theta got tiny. Same size theta as I wrote. She's shrinking away again. And all of that is over 2, all squared. Good. Everybody get some paper out and you do this. In fact, everybody else should do, I'm going to put up one on the side. Plug in for sines and cosines from over there and simplify that down. What should you get? What should you get from that? That's second half of the trig graph, right? Cosine, cosine minus sine theta. What's it add up to? Anybody remember what identity that's from?
Cosine plus
Foil.
That's right, so prove it using these formulas over here. Okay? Cosine of theta is over there, you need cosine of alpha, cosine of beta, etc.
I ran out.
Okay, so you have to square all that out.
I ran out.
Is it okay if I do my little orange stuff a little?
No. Just
Oh.
X square is all over 4. That one squared, twice the product plus that one squared.
No, that's not how it works.
Everybody should be doing this one or what she's doing. Just see it work out yourself.
Oh, we can't see what she's doing.
You're supposed to do it yourself.
Again, this one you can also do. See what that adds up to.
Samantha, you're changing.
I'm thinking.
She's
This
thinking.
is my little notes here.
That's fine.
What I do.
What do you do with exponents?
Whatever I'm running out of speed, blank 5 on my
Multiply
page. 5,000.
B to the A, B to the P, B to the Q is B to the P plus Q.
So that's the thing, does not equal beta.
Stop gassing. Running out of speed. Running out of speed.
Then you need another line.
Well, like, humility.
Right? Sorry. Use your paper sideways if you have to. If you otherwise use more than one line for it. Mhm. Yes, what happens when you add?
No, I'm saying if you're not.
What exponent do you get when you add those two things? 0. What's e to the 0? What's e to the 0? That's right. Fraction with a 4. It may not be a 4 in the box. It's 2i squared. Minus. Your line. Okay, so now you need this one squared. I expect when you take trig in your pre-calc class, they will prove them, maybe they'll prove them. If they prove them, you'll have a faster way of proving all of them using the complex formulas. I'm sure you didn't do it in your pre-calc class.
Not vice
It's gonna be wrong.
Okay, equals. Okay, what do you do with the two minuses?
That's wrong.
Make them both pluses.
That is still wrong.
Squared it.
Okay, now put it all over a common denominator to see what's left.
It's not as if she was good.
I know this one.
You don't know.
Now you're going to multiply these out by the distributive. So all over a common denominator of 4. Denominator is multiplied. The numerator, you get this one times this one, plus this one times this one, plus this one times that one, plus this one times that one. All 4 possibilities. So put a big horizontal bar with a 4 on it. Product of the denominator. And then I got this times this, plus this times this, plus this times this, plus this times this. And you do it with using the exponent rule. Okay? Cancel a 2 equals, cancel, it'll have a 2 in the denominator. So draw your horizontal bar, draw your fraction bar, what's in the bottom, what's left in the top, cancel a 2. Okay, now you made a mistake. You have to cancel a 2 in every factor. Okay. Now look at that formula, compare it to one of them over there. Which one is it? So equals cosine of what? It's not theta, because this doesn't have just thetas in it. It's 2 thetas. Okay, so you just proved the double angle formula for cosine. You just proved this formula. You started with the complicated sides, multiplied it all out, and got the easier side. Yeah, Mark?
This right, this,
Except you've got to keep the I. It's I times the quantity A plus 1. How are the other people back there coming? Which ones of these identities have you got? Anybody?
Oh, this is this.
Who's written one of these out? Multiplied it out. That's what you're supposed to be doing.
wait.
Who's lost?
Wait, I need to. What if I
I times minus I. What is I times minus I? Minus I squared. What's I squared? Oh, but you're adding them. You're not multiplying. The exponent is out. One is a positive number, the other is a negative number. And you add them up. What do you get? What's I theta minus I theta? What is I theta minus I theta?
0?
0. And what's e to the 0?
0. Why?
1. You got halfway there. Okay? So, Samantha asked me about this while she was writing in her little stuff over here. E to the I theta, e to the minus I theta is equal to 1.
But
They are inverses of each
here
other.
on
Yes, they're conjugates of each other, and they have length 1, so they're inverses.
And you're on nothing.
Pardon me?
And you're on
What are I?
A.
Sure, then you add them up. So if you have e to the I alpha, e to the minus I beta, you get e to the I alpha minus beta. You add the exponents and factor out 9. Okay? He's working on this one. Anybody else actually working on it? Okay.
I mean,
You should all get these.
no.
See what they come down to. I think you should know the answer before you start. However, it's good to see the algebra do it. Yes, you're supposed to do it. Julian, are you writing them? You don't look like you're writing. You're staring at your paper. What's the first one?
Up your house.
Wait, are those separate?
They are two separate identities.
Sine, cosine, cosine.
Wait,
We have sine, cosine, cosine, sine, cosine, cosine, sine, sine. Okay? You want to know what they add up to, but I want you to see that the algebra does it.
this right for these.
This and this.
See your handwriting.
Like G. Minus plus. Cosine, cosine. Yes, minus.
Yeah.
Yeah, the bottoms of these, what's 2i times 2i? 4i squared. And what's I squared?
Okay, so.
What's I squared? I is the square root of
It's negative.
negative 1. So 2i times 2i.
No, 4.
Plus 4 or minus? 2 times 2, I times I. 2 times 2 is 4, I times I is a minus sign. It's minus 1. So you get 4 times minus 1, it's minus 4 down there. Now you gotta multiply out these numerators. Same way you did before. Except you've got an extra minus sign in between.
Do I subtract instead of add?
You have this one times that, plus this one times that, but it has a minus. And then this one times that, and this one times that. That was, yeah, they're both minuses. So the minus ones, when they're multiplied, become a positive. But the cross terms,
Right, come on.
this times that, and
Fuck me,
this
it's
times
easy.
that.
You're very there.
How
You substitute the sine and cosine in this equation and you multiply it out and
do you do that?
Dawson, have you tried doing it?
multiply it by that. But you have to.
I'll give you 10.
It's mechanical. It's 5 minutes.
5 minutes is a long time.
Unless you write them down, you don't realize how they simplify.
Some of them simplify to 1. E to the I theta times e to the minus I theta.
Hey, what other trig identities are there?
This is why you That's what I did for algebra. It's like find factor. It's like, okay. It's like factor. I just used the factor to make it.
This is that square. Like, that's exactly what's
Oh,
Yeah.
we can do the,
Well, I did that.
You just copy.
No, I actually did.
here's another one. This is the product and sum identity. And somebody sit down and do this one. It is, hold on, let me write this down.
You can't get on the end. Your game was being built.
Cosine of alpha minus beta plus cosine of alpha plus beta equals. What's that equal to? And that's again one of the identities in there. Write it down, each of the pieces, add them up, and see what it simplifies to. Point is, you should be, pick out any one of the identities and plug in these two formulas and see if you get the same thing from both sides.
That's your I know, I did this before. Those two. It was like, hey, it does.
Stacia, you did which one of them?
I got it.
Okay. Have you started on one of those or this one?
I'm starting on.
Why don't you jump to this one, because other people aren't doing it yet.
Hold on, I'm gonna say.
Can you multiply like something with interest? Like, can I combine these two into one?
No, not without using an identity.
Where?
Exactly.
Where?
You
Wait,
can't.
it's right after.
I can't just combine the two functions.
Cosine, cosine, sine, sine. Beta, beta, beta. You multiply these together, there's 4 in the bottom. Multiply these together, you get a minus 4 in the bottom and a minus out front, cancel. And now you multiply the numerators, which is that one times that I alpha beta minus I alpha plus I beta I alpha minus I beta minus I alpha minus I beta. Good. And this one. Now you combine it. Denominator of 4 on everything. And oh wait, it should be a plus sign in the middle. Yeah, it's 4 plus. You're multiplying these two by these two, you get 4 terms. So there's a plus sign. Unless you're at.
Okay, I think
Yeah, you're
I'm gonna go around.
You guys do?
C plus D.
Let's start
A
taking
times C
it.
plus A times
Oh,
B times C plus A times C
what if they
plus
actually
That's why it's got a plus sign.
I don't know. It's like a random girl on campus. I was like, you should
Now you gotta add them all, 4 terms, you got 8 terms, and some of them cancel.
Wait,
No, cosine of alpha minus beta is not cosine alpha minus cosine beta, right?
Yeah.
What I want you to do is write down cosine of alpha minus beta using the complex formula, okay? And this one, and then put them over a common denominator.
Sorry. What?
Yes, that was way too simple. Yeah.
Mike, did you do those?
Okay, so which one
No.
cancel?
No.
The 4 cross terms. You get 2 of those, 2 of those.
So you did it?
Right? And then you compare this to that. The 2 and the 4 cancel to a 2, right? And so you half this guy. And you do the I alpha plus beta. You do the minus alpha plus beta. Same as that cosine formula, but with alpha plus beta here, here, and here.
So I did that right.
Yes. Now you did it right.
That's a plus.
Admin erasure.
Which means it's a positive.
yeah. I know that, and I'm not even doing
A character.
I'm going to recollect the folders from the name tags. You can keep your name tag, but I'll take the folder, the phone folder back from you later. Okay, or now.
Oh, yeah, because it's
That way we can reuse them. Sure, give me back. You can keep the name tag out of them. Take back the plastic folder.
It made it great, actually. I think you feel better.
So that's what that was.
Totally.
Okay, has anybody done this one yet? Which one have you done? The first one? Okay, come and write it on the board.
I'm just like, I can't just read it. I know, and electronic races.
Jeremy's mind not.
Were you doing?
Okay, she's doing the cosine, cosine, minus sine, sine.
This is like Ian was watching her. And he just
So which one did you do, Russell?
I had to write it down. I was like, you got to undersign it. That was the only mistake in that.
Yeah, this one
It's supposed to be my
You guys are very social. You know each other too well.
What's email? You show me like it's crazy. It's like gets all the chemicals like
Nothing could be worse than this.
Oh, where is it?
So which ones have you done? And they all work out neatly? Show me one of them.
Doesn't make sense.
Multiply those together. What happens to your cross terms in the product?
All the time on the
You've got this times that, and this times that. What happens to this times this, and this times that?
Barb, you done?
There are two more terms in here. Likewise, multiplying those, there are two more terms in here.
You done? All of them?
Right?
All three?
Foil, first times first, outers, inners, last.
So, the internet's like.
Wow, like cool.
There's two more terms. This, and two more terms. It's going to turn out that they cancel, but they are there to start with. Alpha minus beta, alpha minus, you need parentheses, but the alpha multiplies, the I multiplies both of them. And the I multiplies both of them, right? And
Yeah, I know that's what this means.
so this is alpha minus beta. Okay, so the parentheses means the I gets distributed. So this one's going to have a minus I alpha plus I beta. This is minus I alpha minus I beta, which is more like that. And so, you're working on this one, right?
It was like oh, that's the place that the Japanese place.
Oh, I guess I should tell you what the other side is.
Oh yeah, so it was like the launcher. It went down and went inside. They burned it if the app opened. But it's like
Okay, on this one, it looks like you better write that in exponentials and write that in exponentials and see you get the same thing. Because it's rather hard to see that the sum of these is actually just the product. Okay, so write this out, which is what you're doing. Write this out separately and see you get the same answer. So Michael, which ones have you done?
Oh.
Okay, why don't you try that one? Write out both sides separately and see you get the same thing.
Didn't you do it already?
What is that thing called? Yes, I do.
But he can say the same thing. I have a phone. I don't know if it's working.
What's that alpha?
Look, I know 3, Greek left 4. Just watch.
Awesome. Watch. It's a t-shirt.
Okay, so the whole point of today's session is to see that essentially all of the trig identities can be proved by just writing them down in terms of complex variables and seeing that they come out to be the same thing. Okay? These definitions allow you, or formulas for sine and cosine, allow all the symbols to just be simplified. You've learned to write big.
Use these to
That's rough. And that's a bit more problems.
So which ones have you done? Hmm? Cosine, minus sine? Oh, earlier.
I think you can use this one.
Why not? Scares you?
There's a chart of how outside of this line. He said
The Aggies do that. They give us. That's. So the instructor can't help
No,
He says something like that. Dog. It's so dog. And then after you quiet,
back of the chair. That should be an alpha. I don't know.
you were young.
Right? An alpha. That's a beta.
Dude, I was.
Yeah, what I did.
And that's an alpha. And that's a beta.
Those are not.
Okay.
They're yellow.
So
Yeah.
now, multiply these two together.
Are you dark forces? Convincing.
4 terms.
They're purple if you believe.
Numerators are all different.
They're purple if your content and purple. Yeah.
I already did.
I actually missed you that.
I messed up.
This is a big exercise in careful algebra, right?
Yes, I totally watched that.
So which ones did you do?
Super crap. I know.
You're getting there.
We're like,
I think
Sunday.
Okay, quiet. Hannah's going to explain what she wrote on the board. Now you have to be quiet and pay attention.
Okay, the reason it's
B
color
plus.
coded is because the markers kept running out of ink.
That's fine.
So first I substituted, I made 2 sets of cosine theta and sine theta, substituting the theta for alpha and beta. And this is cosine of alpha in that form, and this is cosine beta in that form, and this is sine alpha and sine beta in the same form. And then I multiplied them out and got this long stuff.
Explains with the numerator.
The numerator.
How did you get the terms in the numerator?
Okay, this one is this one times that one. This one is this one times that one. And this
First, outers,
one, outers, which are these 2,
and the third term is
and then the third. This one is
inners.
and yeah, it's these 2, and then this one is last.
Okay.
And then the same is for this one.
Now, how'd you get a +4 in the bottom?
It's the 2 times 2.
Now, the
And
next term, the next one.
this one
Yes,
is a
that needs
negative.
more explanation.
It's a negative 4 down in the bottom because
Why?
I is the square root of -1, and when you multiply I by itself, you square the square root, which turns into -1. So -1 times 2 times 2 is -4. And then I did FOIL and got these.
And how'd you get a +4 in the bottom? It said negative.
The +4 because it's subtracted, and then you cross out this subtraction sign.
Okay.
Look, it's -1 times this fraction, and there's a -1 on top too.
Okay, and how'd you get the numerator?
This one is FOIL, this one is the first,
Tony.
last, first, outside, underneath, last one. In that order, I think. And then, these two and these two cancel out because they're a negative plus each other. And then you get 2 of these, and then 2 of these that you're down here, all divided by a positive 4. And so the 2 cancels out.
Factor the 2 out.
Yeah, you cancel the 2 out, and you get this, which, if you look over there, is the same as the cosine of alpha plus beta.
Everybody like that?
Agreed.
Okay. Anastasia, have you managed to do the one on the board over there yet?
Not yet.
Not yet. Has anybody done that one over there? Pick a side and do your side. And then tell me when you finish one side of it. You'll come right up your side, and somebody else will write their side, and hopefully they'll agree eventually. Luce, have you finished a maplet you were going to make?
Still working on it. I don't think I'll have time to input all the data values, so I think I'll get.
Oh, you're doing data, yes, because for some games.
Yeah.
Okay, you can still email it to me anytime afterwards.
Yeah.
I'm going to probably make a link and a page at the class. If you go to my current classes, one of them is a link there, says 999 complex circle, and I'll put a page on there which has all these maplets for everybody to try each other's maplets. Yes. Yes.
Oh, you can't.
Okay, so you've got the left-hand side, and that's fine. Now you separately have to do the right-hand side and see if it comes out to be the same.
Is that just the answer?
Yeah, you could, it would be better, that's the end of the left-hand side.
Oh, okay.
Now do the right-hand side. See
I
if
thought
you
it
get
gets
the same.
simpler than that.
Yes. You did the right-hand side?
That's the left-hand part of the cosine alpha.
The left-hand side.
The left-hand half of the.
This?
Yes.
Except that it's got a minus in there and an extra I down here.
But it's cosine alpha.
Oh, it's cosine.
Alpha cosine.
Oh, yes, it is.
And you just multiply
So
by
it's
2.
this.
Yeah, times 2.
Okay. Anastasia, is this what you got? She just pointed out that 2 cosine alpha cosine beta is precisely twice this. Because that was cosine alpha cosine beta. Is this what you have? Except for the 4 in the bottom should be a 2.
Yeah, except for on that side, I have a negative side assigned by the I.
On one of the numerators,
Yes.
did you write this minus I beta minus alpha instead of alpha?
I have minus I alpha minus I beta.
Minus I alpha.
No, the second one's this one. I don't.
Yeah, she has the alpha and beta switch.
For outers, there's a minus I alpha plus I beta, which is this one.
Yes.
And she just wrote it by putting the beta before the alpha.
What?
That's not the one. That one's right. The other one.
This one, what do you have? Minus I
Minus I
alpha.
alpha minus I beta.
Where did that come from?
Well, I
This
don't.
times this?
I took a core from somebody.
With that, this here. Here's a minus I alpha minus
No,
I
the
beta.
other one.
I spent all of our sticks. I shift clicked
Right. Because it was minus I alpha minus beta, so it was minus I alpha. No, right here, minus I alpha.
Minus I beta,
Yeah.
which is the same as this one.
The other one. Sorry, I tried to do the wrong thing.
Born?
Minus.
E to the I,
plus. Yeah,
plus
I
I,
just-
minus I alpha plus I beta.
And minus I alpha.
This
Minus
is
I alpha
5
plus
minutes
I
down.
beta.
Okay.
Minus I alpha plus I beta.
Oh, I see. Yeah, I understand. Yeah.
Okay? So that proves the identity. Okay? Good. Okay. I have covered everything I want to cover. I really recommend you sit down and do proofs of these and get the algebra to work out for yourself so you understand why they're true. In summary, we have the definitions, Mark. We have the definitions of trig functions. They were originally given in triangle form. Then we used circles to define them. Then we proved some of the identities just looking at the circles, namely parity, flipping using minus theta. And the complementary and supplementary angles we got straight out of the circle definition. And then we proved the cosine of a difference and the cosine of a sum by actually looking at a circle and finding distances, lengths of chords. And you did one of those as homework, right?
You did?
Yes, and turned it in. And I marked, did I give them back? Here they are. I haven't given them all back. Mark.
Yay.
Audrey. Jeremy. Chloe. Hannah. Samantha. Annie. Thompson. Yeah, I only gave A's. I didn't write any grades on those. Hart. Michael. It's interesting. No two people have the same first names in this class. Julian. Anastasia. Tony.
A lot of the same last name.
Okay. And two people never didn't turn it all in. Okay, so that's all the homework I got, and it's now been returned. So then we proved the cosine of a sum and difference geometrically. You really only need one of the two of them, and then using the replacing beta by minus beta, you can get the other one. And then from the cosine of a sum or difference, Mark, Luke, quiet. From the cosine of a sum and a difference, you can get the sine formula because they're complementary. And you can get the double angle formulas, the square formulas, all just algebraic. And the only other two which need to go back to first principles are the law of sines and the law of cosines. We did them geometrically, okay? And so we proved all these identities. Then we talked about polar coordinates, where the point x, y become r cosine theta and r sine theta. Then we took a look at complex numbers and thought about them in the plane and saw they can be plotted as rectangular coordinates or polar coordinates, which led to the exponential formula for sines and cosines, and from them we could reprove all the identities. So that's basically what I covered this term. Okay, this meeting is not a term, I don't know what it is. Okay, so why don't we move downstairs, and I will give you certificates and signature pages, and you can finish up Maplets.